Hello everyone, in this video I'll be talking about Gradle and Circle CI. So Gradle is a build tool that will help us build our Java project, and Circle CI is a continuous integration tool that we'll be using in order to maintain our project and verify that everything is running properly, all the test cases are passing, and the software is working. So let's jump into it. So the first thing we need to cover, even before talking about CI and Gradle itself, is why we're doing this. So right now, whenever you're developing software, you want to make sure that you're always delivering. So you're going to have a bunch of people in your team working in new features, different features, and like every 2 weeks or so, you want to show something. If you're working for a company, your boss is going to ask you, how is your progress, like, you want to show code. Or if you're developing your own startup and business, you want to always be putting out new features for your users. So the software process changed a lot, and something emerged from the early 2000s to now. We have this new thing called DevOps, which is developer operations, which means we're always developing code, and we want to make operations automatic, which means that we want to make a system that whenever we push something to Git or we update our code base, it automatically tests everything and verifies everything for us. So that's what DevOps is going to be, between committing a change to a system and the change being placed into normal production. So between like we committing something to GitHub and that piece of code being live and available for everybody to use, that's what DevOps is. It's going to be a bunch of like techniques we're going to use and services that will enable us to make this process automatic. So with push code, code will get verified, will get built, will get backed, and will get delivered to the user. Okay, so how do we do this, right? So looking back at the process, we're gonna have some code over here on the left. So it's just an example here. We're gonna be pushing that code to GitHub, and as soon as GitHub gets that code, we're gonna have a CI tool. In this case, we're gonna be using Circle CI to do that. And the CI tool, which is a continuous integration tool, will be watching for changes on GitHub. And whenever it sees those changes, it will trigger a build process. And for the build process, we're going to use something called Gradle, which is a build tool. We're going to get into that in a second, but like in a nutshell, we got to understand this flow before anything. So we're going to be pushing some code. We want GitHub to get that code. As soon as that code is stored inside GitHub, then we're going to have a third-party service called Circle CI, and that will build our code and verify that all the test cases are working properly. That's it. And obviously, like for the scope of this presentation, we're only going to be talking about testing the code, but you can also do something called CD, which is not in the scope of this talk, but it's called continuous delivery, where besides testing your code, you're also going to deploy that, and your user are going to see that those changes live. But we're going to talk about that later in the course. Anyway, so talking about build tools, right? We've been talking about Gradle all the time, but we got to understand why we're using Gradle as well. So before Gradle, we had other tools that people in the Java community used to work with. The first one is Apache Ant, and it's the very like first tool like known in the Java community. It was developed in the early 2000s, and it was basically a replacement for the make tool. So if you worked with C or C++ before, or any low-level language, you probably wrote a make file already. And so the make file was a really rusty way to set a set of instructions for your software to compile. So for example, in a C program, you would specify every single file you need to compile, every single dependency you need to link. And it was more specific for the C environment, like the C, C++ environment. So the Java community came up and said, you know, we want a new system. So they developed Apache Ant. It was during the same time that Apache Tomcat was originated. And they developed the system in order to be like more Java friendly in a nutshell. But it's quite old by now, like you won't see many projects using it. But it was the very first tool that was developed by the community. The second one is Apache Maven, and you're still going to see this one being used till this day, actually. It was developed obviously after Apache Ant, and it's easier to write. So with both Ant and Maven, we're going to be writing files, like a configuration file with all of the steps that we need to do in order to build our software. With Maven, that step by step, it's easier to do compared to Ant. It actually has some really cool features. You can look for dependencies online for us. So let's say you want to install JUnit or something in your project. It will look for JUnit in a repository online on the internet, and will find it for you and download it for you and other really cool stuff. So Maven is a little bit more modern. It's easier to write, but still, we have newer technology that actually makes this process even easier. So the third platform that we have, the third build tool platform that we have is Gradle. This one it was originated, I think, in 2010, and it's also open source. It's not supported by the Apache Foundation, but it's pretty good as well. If you ever develop like Java web applications, it is well known and used for a framework called Spring Boot in the Java community, which is generally used for developing web APIs. But you're also going to see Gradle being used in Android development. So if you develop your Android app, in order to build your Android application, Android is going to be using Gradle in the background to do that. And so yeah, so it's quite useful. It's the most modern approach in order to build your project. And yeah, it came after Apache Ant and Apache Maven. And for both Ant and Maven, we were writing like huge XML files with a bunch of tags, and they were quite like convoluted. With Gradle, we have something called a domain-specific language, and we can actually use a programming language in order to describe our dependencies file, which is pretty cool as well. So yeah, besides that, Gradle was designed for multi-project builds, which can grow quite large. And the most important thing, it supports incremental builds by intelligently determining which parts of the build tree are up to date. So you can imagine that you're building a software, it can get quite slow over time. You have more dependencies, more packages. So you want to make sure you're caching all of those, and Gradle is really good at that. Anyway, so that's the reason we're using Gradle right now. But still, keep in mind, you're going to see Maven and Apache Ant being used in the community as well. So now that we understand a little bit about build tools, let's jump to the CI process. So we're talking about DevOps here, right? Developer operations. So Gradle is the tool we're going to use to build our projects, and that's part of DevOps in general. And the second part is the actual continuous integration pipeline. So right here, we're developing some code, and then we want to make sure that we can test that code and that code actually runs in your local machine. And finally, you want to integrate that code with your peers' code. So right now in the project, every single one of you are working in different branches, right? So you may have a branch X, Y, and Z, but eventually you guys need to merge everything all together inside a master branch, which is going to be where the final version of the software is going to be located. So the idea here with continuous integration is that whenever people are working in different features and we merge things together, things are going to break. You're going to have merge conflicts. Maybe you wrote something or you changed the function and you broke somebody's test. Maybe somebody did that to your code. So eventually things are going to break. So the idea with continuous integration here is to maintain and verify that whenever somebody pushes code or somebody merges code to master, which is the final version of your project, everything will be working just fine. So what options we have for continuous integration? So how does it happen, right? Is it magic? Whenever we push to GitHub, like magically every single task will be executed, Gradle will be executed magically? No, that's not how it works. So for continuous integration, we'll have two options here. Either we can create our own server, which is pretty complex, and we're not going to cover that here. And for that, you can use something called Jenkins, which is an open source project that you can set up in your own machine or like a remote machine, and that will be watching for changes in your GitHub repository, and based on those changes, it will run the build process for you. The second option is use the software as a platform, software as a service platform. So for those, you're going to have Travis CI and Circle CI. Those are the most famous ones. There are other options in the market, but those are free. They're extremely easy to use. And what are those companies are actually offering are machines on the cloud that will be watching for a GitHub account or GitHub repository, and whenever some changes happens inside the GitHub repository, it will trigger the build process for us. So it will get our code, build our code, run test cases, and verify that everything works properly. That's what it's doing right now. So we're going to be using software as a service. We're going to be we're going to be using Circle CI as a provider for those cloud machines and everything. So just keep that in mind. So how does this work? Whenever GitHub gets some new code, we're going to get new code in the master branch inside GitHub. That will trigger something called a webhook. And the webhook is going to communicate to the service that you selected. In our case, it's going to be Circle CI. And it's going to tell Circle CI, hey, I got some new code in the master branch, and I want you to build it and verify that everything is working properly. So again, let's think about a use case. You have many peers in your project right now. You're all working in different features, and then somebody merged some code to the master branch, and then you merge your code to the master branch. By doing that, then you're breaking, for example, you're breaking one of your peers' test cases. Circle CI, so then the merge process will happen, and you're going to have the latest version inside master, and then Circle CI will get triggered, and Circle CI will run JUnit and a bunch of other stuff. And whenever it runs JUnit, for instance, it will identify that stuff is broken, like the test cases are broken, and by that it will warn you that, hey, the test cases are broken, you should fix it. Obviously, like, since we're in this class, we want to make sure that all of our code works, and we also have test coverage, which means that whenever we run our test cases, they all run properly, and it should be all green. We don't want any functions to be failing or anything like that. So that's where Circle CI actually helps us. Like, it's going to do all this process for us. Like, whenever we push to GitHub, we don't need to do anything else. Circle CI will get the code, we'll build it, we'll run the test, and will let us know if it ran or not, if it worked or not. Okay, so let's jump to it. Okay, let's close it here right now. We can open Eclipse and actually delete this for now, and we're going to create a project from scratch. So, okay, let's delete this, whatever. Again. Oh, wait, gonna close this here and delete the project. Right. Okay, so right now we have an empty project. Obviously, you and your group should already have a project. So for this part, just follow up. There's nothing you need to do. I'm going to just create a simple Java project in order to integrate that with a Gradle project. So we're going to just click here on New, Java project. I'm going to call it Simple App. And inside of that, I'm going to create a new package called con.app. Inside of that, I'm going to create a new Java class. Oh, sorry, a new Java class actually. And we're going to call it main. Start out with a method, and that class should just output something. So I'm going to say system.out .println test, and that's what it is. And finally, I'm going to write some test cases. So I'm going to call JUnit here, call main test, and finish. And yeah, we're going to add JUnit 5. We're going to be using JUnit 5. Keep that in mind. We're going to be, because whenever we start writing our build file, that's going to come in handy. So JUnit 5 is being used here, okay, which is also known as JUnit Jupyter. So we have a test case here, and our test case is broken right now because right now we didn't implement a function, so it's going to call fail not yet implemented. So okay, let's give it a run on this project. So if I click play right now, I should see test, which is pretty much the code inside my main function. And if I click on the test case, I select run as JUnit test case, it should fail, because right now I didn't implement the fail function. So yeah, not yet implemented. So that's it, pretty simple project. So right now, our mission is to install Gradle, right? We want to use the build tool to make this automatic. Right now I'm quite stuck to Eclipse, right? I can't do much here. Like, I can run my code in Eclipse, and I can run my test cases manually, but we want to do, we're going to be using Gradle, and Gradle is going to do that for us. Okay, so the next step, I'm going to open our browser here, open a new tab. Here we go. We're going to type Gradle build tool, so it's gradle.org. Finally, we're going to click on install Gradle. And basically, yeah, so it's gonna tell you like the release version and everything. And the prerequisites section is quite important actually. So Gradle runs on all major operating systems, and you gotta have at least JDK JRE version 7, Java Developer Kit, and Java Runtime Environment version 7 or greater than that. So to check that, we're gonna type CMD. I'm gonna run this as an administrator, and we're gonna type Java version, and that will tell us our current Java version, the current Java version in our system. Right now I have Java version 1.8.0, which is fine because it's greater than Java 7. So you probably are running Java 1.8 or maybe Java 9 or Java 10. All of those versions are fine. Be sure you're running at least 1.8, which is pretty much the stable version right now. And okay, so we can go back here. There's additional resources, we don't need that. And finally, we have installing with a package manager. So how do we install Gradle? To install Gradle, we need a package manager. So this part will depend on your operating system. Right now, I'm using Windows, but in case you're using the Mac operating system, you may need to use a different package manager. In this case, you're going to be using something called Homebrew. It's extremely simple to install, so don't sweat it. You just click here, do the installation process. And why do we need a package manager? Well, let's understand that even before using it, right? So for those who used Linux already, you may have used something called apt-get or any other application like that, and those apps are used for you to install dependencies. So for example, in Ubuntu or like in Linux in general, you're going to be doing like apt-get install, I don't know, let's say LibreOffice or some other application. So apt-get is a package manager. It's going to go on the internet, it's going to look for that piece of software for you, it's going to come back with it, and it's going to install it for you. So that's what we need right now. We need a software that is going to go to the cloud, it's going to find Gradle, it's going to come back with it, and it's going to install Gradle for us. Since I'm using Windows, there's a package manager for Windows that is called Chocolatey. That's the one we're going to use. It's pretty simple to install actually. So we're going to click on that, open a new tab, and you can click here on install Chocolatey now. And the first thing it asks, you need to have a CMD actually with admin power. So we have here right now administrator power. To do that, again, just open the Windows tab, type CMD, run as administrator, and there we have it. Finally, you can come here on install with CMD. So we're going to just copy this little command here, and by right-clicking with the mouse inside of the command prompt, it's going to actually paste it for us and execute the command. So it's installing right now. I already have Chocolatey installed, but it's going to try to install it anyways, and eventually it's going to get installed. And how do you check if successfully installed? You just need to type choco, and it should tell you the version you're using and a bunch of other information, but it should at least output the version. So there we have it. We have Chocolatey installed. Now we can just copy this command over here, choco install Gradle. Same thing, we're going to just right click on the command prompt. Oh, let me just copy this here and right click. Let me see if there's any spaces here. Oh, okay. And okay. So right now I already have it installed, but you probably don't have Gradle installed. So it will do an installation process. It will download Gradle and do a bunch of things. So you can pause the video right now and wait for the installation process to end. But anyways, I got it installed, so great. So we have Gradle in our system, but how do we actually make Gradle work with our project, right? So to do that, we're going to right-click the project here. We're going to go for Properties, and inside Properties, you're going to find the location parameter here. We can just copy the path. So this is the current path where my code is located. Finally, I'm going to just type cd space and then right click with the mouse, and okay, right click with the mouse, and then I'm inside my project directory. I can type there here, and then I can see everything. The source folder is here, bin settings and everything. And inside this folder, we're gonna type Gradle space init, and that will initialize Gradle inside of our project. Okay, and Gradle is going to ask us a bunch of questions actually. So the first question is, which kind of application are you running right now? Gradle works with a bunch of applications actually. Not only works with Java apps, but we're going to use, it can also work with like Groovy applications, Kotlin applications, Scala applications, and even C++ applications. So in our case here, we're running a Java application, so we're going to select option 6. Second question is, which language, which DSL you want to use? So the domain specific language. So remember, with Maven and Ent, we were using XML, but now we can actually use a programming language in order to write our build file. We're going to be using Groovy for this example. And finally, it asks, hey, are you using any test frameworks? And yeah, we are. We're using JUnit, so we're going to type 1 as well. It will ask us for a project name. We can just keep the full name here, so example app, so just click enter. And the source package, we can also just click enter here, and it should be enough. So great, now Gradle is part of our project. But okay, how is it part of our project? What happened, right? So if we go back to Eclipse, and we click cancel here, we should be able to refresh the project. And there you have it, we have new stuff. Like, so Gradle just created 2 new packages for us, actually 4 new packages. So main.java.exampleApp and a main.resource package as well. Then it also created a test.java example app package and a test.resources package. Okay, great. So if we open those packages, you're going to also notice it created a class, a simple class, and a simple test file. But we're going to delete those. We don't need those. So we're going to delete app test. We're going to delete app Java. And something we're going to need to do right now is migrate our files to the specific packages that were created by Gradle, just for simplicity. So we're going to move main.java to the main Java example app. Okay. And we're going to move the main test file to the main to the test.java example app. So yeah, it's quite simple actually. You're going to be moving all your Java files or your actual application files to your app name folder, to the main.java package actually. And whatever test case you have, you're going to be moving those to test.java. Okay, we're going to delete our previous package here. We don't need that anymore. So now our code is here, main.java example app main, then test.java example app main test, and that's pretty much it. Okay, so now we have it, but like, does it work? Does it? How is it supposed to work? Right. So if we open the terminal again, inside the terminal, we should be able to type Gradle and then build, and that will run a series of steps to us. And right now it's failing, and we're going to understand why. So as soon as I run Gradle build, it's going to try to do the build process for us. But right now it doesn't know much about our project, and it's complaining about some stuff. The first thing it's complaining about is it couldn't find JUnit Jupyter, the JUnit Jupyter package. So it's complaining that it couldn't find this package, and because it couldn't find it, it couldn't execute the code properly. So we're going to fix that first. But okay, but how do I talk to Gradle? So the main way to talk to Gradle is going to be by using this file over here called build.gradle. So we're going to just double click that. And this file will describe all of those steps. So this is the meat of Gradle here. Gradle is going to get fed with this file and with our source code here. And based on this file, the description that we're going to write here, it's going to know like what it needs to do in order to build our project, right? So the first thing here, we have a plugin section, and in this plugin section we're going to tell which technology are we using right now. So we're going to have like an ID of Java, which means we're using the Java technology, and we have an application running. Okay, great. The second tag we're going to be using is repositories. That basically tells Gradle that, hey, whenever we install a new dependency to our project, you should look online at this repository here. We're going to be using the default one here, JCenter. So that means that whenever we install new dependencies to the app, JUnit is a dependency, for instance. Like, it doesn't come with the Java Developer Kit. So we need to install it from somewhere. A way to do it, you could go to the JUnit website and get the dependency, get the jar file, and import that to your project. But that's a lot of work, right? And we want a build tool that is able to do that for us. And so yeah, that's what the repository section does. Whenever we install a new dependency using Gradle, Gradle will look at that dependency online and try to figure it out and install it to us. Okay, but where do I specify my dependencies? Over here. So we have a dependency section. So the dependency section is all the dependencies needed to run the project. Right now, since we just started like a simple Gradle file, it will come with this guy here, Google Guava. We can just remove that. We're not using that dependency in our project, but we are using JUnit, right? And right now in the dependency section, it's going to be we're going to have like the test implementation. We're going to have JUnit 4.12. Well, right now in my project, I'm using JUnit 5, so that's not actually the dependency that I need. So I need something else. I need JUnit 5. So for that, I'm going to get that in a second. So let me copy this here and go back here. Okay, so you can pause the video and type that for yourself. But basically, or maybe you're using JUnit 4 in your project, so be mindful of which version you're using. You're basically telling Gradle, hey, my project needs this version of JUnit to work properly. Again, right now I'm using version 5, but you may be using something different. So if you're using version 5, you can just copy paste this command. Maybe if you're using version 4, you can just skip this line here, which will install JUnit 4 for you. Okay, and this is the interesting part. This is the magic of Gradle. It's going to look at this line and it's going to go to this repository on the in the cloud, in the internet, and it's going to find out, okay, hey, I found a JUnit for you, and it's going to install it inside our project. So it's pretty cool. So I'm going to just remove this, and there we have it. So right now we know that we're going to run a project. Our project runs with Java. We know where in the cloud we should be looking. We're going to be looking for the JCenter repository. And we know our dependencies, right? So right now our single dependency is JUnit. Great, awesome. The final thing is define the main class for the application. So the main class is the main entry point for the app. Right now we have main.java example app, and we have a main.java file, and that has a main function, right? So if we go back here, right now it's using example app.app. We removed .app, we removed the app.java file, so we're going to erase that, and we're going to select our main.java file. So again, the file you want to use right here is the file that it's calling the main function. It's the starting point for your program. So you may have called it something different, like maybe app.java or entry point or whatever. So right in my case, I just call it main. So we're going to go back here, and we're going to type main. Great, we're going to save that, and there we have it. So this file is pretty solid. We can try running it right now again. So let's give it a shot. And if we run it again, Gradle build, it builds successfully. Oh, great. So it seems everything is working, right? It was failing before, and now it was able to find JUnit and everything. But there's something weird here, right? Because if we open our test cases, it should be failing by now. So we need to write a little bit more configuration within the Gradle file, actually. So let's open Gradle build. So it's building the project successfully. It's able to resolve the JUnit library, but it's not running our test cases. And we really want to do that. So for that, we're going to just create a new section called tests. Open close brackets. And inside this section, we're going to type something. Use JUnit. And it's going to be exactly like I'm typing right now. Platform. So you need to type that out. And also we're going to do something called test login. And inside of that, we're going to specify events. Inside events, we're going to say test, then skipped, and finally failed. So, okay, now that we typed that everything, like let's think about this. Right now, what we just did is a Gradle task. So we specify a task called test. So we're basically telling Gradle, hey, whenever you build my app, I want you to test it. And testing means you're going to use the JUnit platform. So this guy here that we specified, you're going to use JUnit, and you're going to check for some events. So those events are going to be if the test passed, if they were skipped, or if they failed. Pretty simple, okay? So we're going to save this right now. I'm going to open the command prompt again, and we're going to run build again. And great, now it failed. And it will tell you, it will actually tell us why it failed. So it's saying here, hey, I tried running the test function, and I got like, so inside the main test file on line 16, my test actually failed. So we can check that. So main test file, line 16, yeah, it should fail, right? So, okay, so let's fix that. Right now, I'm gonna just comment this test case, so it works. Great, so we're gonna just click enter. Oh, actually, just if you're interested about it, Gradle is quite cool. It actually generates an HTML file with a report of your test cases, so you can copy this over here. So I'm gonna just Ctrl+C, and you can open your browser and type that out. So the exact path here. And it's going to open this page for you, and this page tells you like which tests, how many tests got executed, how many failed, how many were ignored, and your successful test rate. So for those that don't like the terminal a lot, you can actually go over here, and you can even click the failed test case. It will give you a complete log of why it failed, which is quite cool. Right now, not yet implemented, which makes sense because we did not implement our test case. But anyways, it's just a cool feature that you can use. It generates this HTML file with a bunch of information that is quite useful. Another way to run this as well, it's by just running builds, and then you can run --info, and it's right here. So if you run with --info, it's going to give you a little bit more information. So we can type enter. So it gives a lot more information, actually a bunch of stuff that we don't want, but still, it's going to tell us a bunch of other information there, and it's quite useful. So if your test cases are failing, we don't understand, and you want to see a stack trace of the problem, --info will give that information for us. So let's even play a little bit with it. So if I comment this out here, and I come back, and I run info again, it fails, but now it also gives me like a little stack trace, so not yet implemented is here. Okay, great. So let's comment this in again. So we have something that's quite working, but we want more, right? Gradle right now, it's testing if our software is working, but we want a little bit more. We want to be able we want Gradle to generate a jar file, to generate an executable out of our project. So how do we do that, right? If we used Eclipse, we would manually click here and generate, export, and then we would generate a jar file, and it's a manual process. But with Gradle, we can specify that just once, and then it does it for us every single time. So we can just say, we're going to just type in a new task called jar, and this new task will contain something called a manifest. And inside the manifest, we're going to have attributes. And the main attribute is the main class. And then we have, we need to specify the main class of our project. So this is, again, is the entry point of our project. Right now the entry point is main.java.example main. So example app.main. Great. So that's the entry point. Okay, great. So right now, if I come back and let me run build again without the info. So whenever I run build, it's going to run all of my tasks, right? I have two tasks right now, which is testing to see if the software is working properly, and right after that, generating a jar file, an executable file out of my code. Great. So it built successfully. It was able to run all the tests. So you can see here that it first executed all the test cases. Right now I just have one, which is the task, the void test function here. But it was able to run all the test cases, and right after that, it generated the jar, right? So we can go here right now to the File Explorer, and we can go to Desktop, Workspace, Example App, and if we open the build folder, it's going to generate this build folder for us. You can then click on Libs, and you should see Example Lab over there. Nice, so it generated the jar file for us, just like we specified, right? Okay, let's say I want to run this jar file. You can just open your command prompt. You can navigate to cd build, then cd libs, and then if you type dir here, you're going to see that example jar is inside. Then you can type java-jar, and then example app jar. And then we'll run our jar file. And great, it runs and it outputs test, which is pretty much what our app is doing right now. It's just outputting test. Okay, that's sweet. So we have something that works. Our Gradle file is pretty stable by now. It's doing everything we want. So just a quick recap. We installed Gradle. We initialized Gradle inside our project by doing Gradle init. And whenever we do Gradle init, it's going to initialize all of those cool files here. So build.gradle and settings.gradle and everything. Inside the build file is going to be the recipe for that we're going to give Gradle in order for Gradle to build our project, run tests, and package our app and make like an executable or something else. So right now, again, we have a plugin section. In the plugin section, we're basically telling Gradle which kind of technology we're using. In the repository section, we're telling Gradle where it should look for the dependencies. So right now, when we ran Gradle build, it didn't have JUnit. So it looked online and it downloaded JUnit for us, which is pretty cool. So the repository sections is where it should look for dependency. Right now, just keep JCenter. Is pretty much, it has everything we need. Inside the dependency section, we specified our dependency. Well, it's a test implementation dependency, and we specified that it's JUnit 5, and that's awesome. And right after that, we created two tasks, right? So those are tasks. And the first task is a test task. And inside of that task, we basically told Gradle to use JUnit, so the JUnit that we just installed. And we also told it to verify if tests passed, or if they were skipped, or if they failed. So that's what it's basically happening here. And then we specify a second task, and it's a jar task. So in case this one works, then we're going to generate a jar file. And inside of that, we basically specify the entry point of our program, so our app. So our entry point is main.java.example.app.main, so main.java.example.app.main. So it's the package name plus the file name. And again, remember that this guy here needs to be the one containing the public static void main function, which is the entry point of your app. And after doing that, finally we specify a main class to Gradle. Right now our main class is example.app.main. Pretty simple. And that's it. So in 43 lines, and we didn't even write 43 lines. Gradle did most of the job for us. We were actually able to write our build file. Quite simple, but okay, so it runs in my machine, but I want to feed Circle CI or whatever continuous integration service with it, and it should be able to run it, right? So we're halfway through right now. We're able to build our app locally, but we want it to be done automatically whenever we push to our GitHub repository. Okay, so in order to do that, first thing we need to do is we need to push this. Again, you don't need to follow this section right now. I'm gonna just create a repository for my project. So I'm gonna first off open GitHub here, and you guys already have that. You guys already have a repo for your project, so there's no need to follow these steps right now. So I'm gonna create a new one, and I'm gonna call it example app. So example app for class demo. We're going to initialize that repository right now. Okay, I'm going to just copy this guy here. And Great. Go back here, back here. We're gonna type 2 minutes. Again, you guys don't need to do this. Just doing this because I don't have my code over there. So I'm gonna just copy this here. There we go. And finally, I'm gonna add everything. Commits. This is our first commit. And we're gonna then push to master. Super simple. So if we refresh our screen right now, we have our code right now, which is great. So we have our code inside GitHub, inside a master branch. Sweet. So the next step is going to Circle CI. So right now you should follow the steps. So let's go to circleci.com. And then here you can click on Go to App. Yeah, right now even I'm gonna just log out so we do the entire process together. So you can actually click on Login, and then you're gonna log in with your GitHub. And right now it already has my GitHub credentials, but it will basically ask for your GitHub username and password. Just type it out. I'm gonna wait for you for a second. Okay, so you just type it and then it's gonna log into this interface. Right now I have some other projects going on, like what really matters here is you're gonna click on Add Projects, and right now Add Projects will have access to all our Git. You can see here, those are all my my GitHub repositories, and we have example app over here, which is one of them. So we're gonna click over here on Setup Projects, and that's really cool. Like inside the repository, Circle CI was able to verify that I'm running a Gradle Java application. So it selected Linux as my operating system to build my code, which is fine. And the language it selected is Java, and it knows I'm using the Gradle build system. And how does it know it? Obviously because I have a bunch of Gradle files, specific Gradle files inside of my project, and Circle CI is able to detect that. So okay, so what are the steps? So the next steps are actually are described here, and those are quite straightforward. The first thing it asks for us to do is to create a folder named Circle CI, .Circle CI actually. That's important. So we're gonna copy this. We're gonna go back. So again, remember, I'm on the root of my project. Users Daniel desktop workspace example app. So inside of that, and again, you can find your project path by going here, properties, and there is it. And okay, so let me go back here. So the next step is creating a directory. To do that, you're going to just type mk there, and then I'm going to use .circle CI. Great. So if I do there again, I should see a Circle CI directory here. Here we go, Circle CI. Then I'm going to navigate inside of it, Circle CI. And inside of that guy, it asks me to create a config file. So we're going to create a config file inside of it. Okay, great. So let's just copy this, config.yaml. And let's open, we can even do this with Eclipse. Or let's see if we can do this with Eclipse. So refresh. Oh no, we can see that here, that's fine though. We can just open this guy here. You can use the text editor to do that. I'm going to use that. So over here. Oh, sure. I'm going to just create save as desktop workspace, and then we're going to example app and Circle CI, and we're going to just do config.yaml. So yeah, remember to include the extension as well. Save. Great, so we have the file over there. The second step is, okay, so right now we have the file. So if we open the directory here, we can type there, and we have a config.yaml file inside, just like how Circle CI wants. And then the second step is to populate that file. So to populate it, just click on the right side here on copy to clipboard, and it's going to copy some text to our clipboard. Then we can come back to Notepad and just paste this. And this is actually the file that we're going to feed into Circle CI, and Circle CI is going to be able to build our application. I'm going to go over that later, but like just for now, just save this and close the file. Great. So we have a config.yaml file. We have all the instructions inside. Okay, great. And then we need to push that file to GitHub. So we're going to just go back here. And we're going to call git as just add all. Circle CI config. And git push origin master. Okay, great. So now if I refresh my Git repo here, I can actually see that I have a Circle CI folder. Inside of it, I have a config.yaml file, and here's the file. So if we go back to Circle CI, you can call, now you can click, after pushing, remember you got to push it first, then you can click on start building. I'm going to just wait a bit, I'm going to redirect us, and it's going to start building our projects. So right now it's spin up a machine for us, it got our code from the repository, and it got all the Gradle dependencies we had. So anyways, so it downloaded the dependencies, it saved the dependencies in a cache, and it run Gradle tests. And besides Gradle build, another way you can actually test if you can actually run a test manually. So you can basically say Gradle test, for example, and that will run the tests task, or you could run Gradle jar as well, and it will run those tasks separately. If you want to run both tasks, then you can just run Gradle build, and that will do testing and building for you. So yeah, so that's how it works. Anyways, so okay, great. So you have the CI pipeline set up, but there's a bunch of stuff that we need to understand. Like we did a bunch of copy pasting and setting up. Like let's understand what's happening. What's happening here. So right now, let's just go back to our text editor. Actually, I'm going to go back to the GitHub repo. So right now, the first thing we did was we created a Circle CI folder because Circle CI asked us to do that. That's fine. But then it asked us to create a config.yaml file. YAML file is just this extension over here. So we can click on that, and it gave us like a sample file we should use. Again, remember that Circle CI detected that we are dealing with a Gradle project, which means this is a Java project that is using Gradle. It automatically detected that to us, because and how did it do that? Well, it had access to our repo, right? And inside of our repo, we have a bunch of Java files, and we also have a bunch of Gradle files. So it was able to tell us, oh, okay, I think you're using Java Gradle application, a Java application that is using the Gradle build tool. So really cool. So Circle CI detected that to us, and it gave us a template of a build configuration file that we should use in order to achieve the integration process. So here we go. So the file is quite simple. I'm not going to cover this file much, but it's important to understand what's happening here. So it's using version 2. So there are many versions of the Circle CI file, the YAML file. Version 2 is the most recent. And then it creates some jobs. And then for this job, it's actually using a virtual machine container with OpenJDK version 8. So it's actually specifying a machine that has Java 1.8 for us. So we don't need to do that. Like that's, again, it seems like magic, but it's pretty much how it goes. Like it's using an image, and this image, this operating system that we are running on top of, it's running Java 1.8. Super simple. Then it specifies a working directory. It called it hit repo. Doesn't really matter. It specified some environment variables for us. So how much heap size, like the heap limit for our JVM, and this is also like not important for now. And this is the important section here, the steps. So inside the file here, it's telling which steps should we do in order to build our project and run, in order to test our code, verify that all the unit tests are working, and create and verify that the software is actually um, acceptable, right? So if the basically checking if the software is broken or not. So the steps is first you're going to check out all the code from GitHub, and then whenever you check out the code from GitHub, it actually does a step here which is called restore cache. So maybe again we're going to be running we're going to be pushing code every single time to GitHub, and whenever we push the code to GitHub, it's going to run Gradle for us every single time, and it's going to gather dependencies and everything. It's a costful task, right? Every single time it needs to gather dependencies, it needs to do a bunch of stuff. So Circle CI actually optimizes that process by caching the information. So whenever we run, we push more than we push master more than once, it's going to execute this process more than once. So the first time it executes the process, it's actually going to go to the Gradle repository, get JUnit, install it, and do a bunch of stuff. But the second time we push to master, it's going to actually use a cache. So it's going to detect that, oh, okay, you're still using JUnit 5, so I have that in my cache, and it's going to get that and install that and use that for us. So this is just a way we can tell Circle CI to be a little bit more efficient. Like, in case our dependencies don't change, just get the cached version of it. Again, this is not important, this is just more of a curiosity matter. So the important part here is checkout, which is going to get the code from GitHub, and then we have a run command here, and then the run command is running Gradle dependencies. And what Gradle dependencies is a command that will install the dependencies for us. So if we even copy paste this here and we run this locally, you're going to be able to see that it will install dependencies. Right now we have everything installed, but it creates a dependency tree here. So right now our single dependency is Jupyter, the JUnit 5.4 version. So this command here will install the dependencies for us. Then we're going to run save cache again. So this is restore cache, and this is save cache. So in case we have ran the process, we're going to save some cache and we're going to restore that cache later. But again, this is not relevant. Anyways, so we're going to check out the code, we're going to install the dependencies, and right after installing it, we're going to run Gradle test. So here we go, Gradle test. And that will run successfully because all of our test cases are running properly. Okay, so that's what the file is doing. Again, a little bit of a step back. Let's look at it again. We're basically specifying a file which is telling Circle CI to use JDK version 1.8, and then we specify a bunch of steps here. It checks out the code from GitHub, then it checks for some cache. It runs Gradle dependencies, which install the dependencies. It's going to save those dependencies in a cache, and finally it's going to run Gradle test. So the three important commands is get the stuff from GitHub, install the dependencies, run the test. If this task here fails, the Circle CI will let us know. So that's what we're going to do right now. So if we come here to our Java projects, we're going to go to the test file, and we're going to comment this out. We're going to go back here, git add all, and breaking tests, git push margin master. Great, so we just pushed. So by now, Circle CI should be aware, and it should kick in like a job to start doing the integration process. So let's get back here, go to jobs, and oh, we have a job running. So this is our previous job, example lab here, and this is our current one. It's called breaking tests. This is my commit message, and oh, and it broke. So it did a bunch of all the steps that we defined in the file. Those are being done here. So it's spinning up the machine for us. Then it's getting our code, so it's doing a git clone in our GitHub repository. Then it's restoring the cache. Then it's installing all the dependencies, saving the cache, and finally it's running Gradle test here. But Gradle test now fails because we did not implement the test function, so now it fails. And again, if I come back here, comment this out, and do the same thing, adds, commits, fixing tests, and then git push project master. You can go back to the task section here, go to jobs. It's going to kick another job here. So it's checking out our code from GitHub. It's doing a bunch of stuff. Gradle dependencies, Gradle tests. And now our test should run just fine. And great, we have a green flag, so success. Okay, nice. So we just integrated our project. We learned a lot about Gradle, how it works, and why we're using it. And then we were able to use Gradle inside of Circle CI, which is a continuous integration service. So again, Circle CI is really fancy, but just get the magic out of it. It's just a machine in a remote location, and that machine pulls your code from GitHub and follows a bunch of instructions. Those instructions, we define those instructions actually inside a config.yaml file. So we configure like all the steps that it needs to be done. It's not magical. Like we told Circle CI to get our code, then to install the dependencies, and finally to run the test. So it's not magic. It's actually quite explicit. We need to tell Circle CI, but we only tell it once. And imagine if you're actually deploying software in the real world, it's pretty hard. Like every single time if you're using Eclipse, you would need to run your tests, and then you need to pack it, and then you need to distribute it to your users. That doesn't work, right? And actually, even if you're working alone, it may work. You may be able to do that. It's quite boring, but it's feasible. The problem is whenever you're working with a big team, eventually you're gonna have a bunch of test cases, a bunch of functions, a bunch of code that's gonna get mixed up together, and things will break. So how do you do that? You're going to need to assign somebody to just build and verify code from time to time. No, we don't need that, right? We're going to use Circle CI or any CI solution to do that, and we're going to use Gradle or any build tool to make the build process automatic. So we don't need to manually click things around and do that. We're going to just write a file that will teach how to build our project, and then we can feed this file to Circle CI as well, and we can tell Circle CI to gather code. And with our code, that's important as well. Like whenever we do checkouts, we're getting all of our code. So if we check the root of our repository, we have all the Gradle files here. The build.gradle file is here. So that's what Circle CI is using. So the same build file that you can use locally, Circle CI, which has a machine somewhere in the US or somewhere else, will be able to get this file and run all of the appropriate Maven Gradle commands for you. So that's it. Now you just integrated your project with Circle CI. Congratulations, you have it running, and that's about it. That's the tutorial. If you have any questions, submit those in the Moodle page in order to get help. But again, remember, this is not magic. Like whenever you're setting up your build Gradle file, be careful. Like maybe you're using a different version of JUnit, so check that. Check which version you are using right now. If you're using any other libraries, you can research online and find how to add new dependencies to your project. But as you guys saw, it's a pretty simple process, and make sure you don't have any typos or anything. And yeah, and if you guys have any questions, just submit those in the Moodle forum page. That's it. Thank you very much, guys.